Good morning, I'm Mr. Precella, sitting here with my Math 1325 class, and we're working on some antiderivative problems. Some of these require u-substitutions and some of them don't, so we'll just see how they handle this. When I look here, I notice these radicals. I know what I have to do with radicals. It's the same thing I do when I'm differentiating. What do I have to do? Rewrite them using exponents, so that's a 7 over x to the 1/2 plus just 7x to the 1/2 dx. And what do y'all think? Are we going to need a u-substitution? Yes. One thing I noticed is the 7 over x to the 1/2. I think I'm going to rewrite that right off before I do anything else. Pick that x to the 1/2 up, move it up there, so I have 7x to the negative 1/2 plus the 7x to the 1/2 dx. So looking at that, what do y'all think? Do we need a u-substitution or not? Do we have quantities raised to powers? No, it's just a single variable in each case. A variable raised to a power, we can anti-differentiate that using that power rule. I don't think we need a u-substitution. So I bring down the 7. I have an x, new exponent. What's the new exponent going to be? Negative 1/2 plus 1, negative 1/2 plus 2/2, that gives me a positive 1/2, divide by positive 1/2 plus, this plus I'm writing down, this plus is that plus right there. So I have a 7x, new exponent, 1/2 plus 2/2, that's 3/2, divide by 3/2. Anything else? Plus my constant c. Compound fractions. What's my trick to simplify the first? So I'm going to multiply the minor denominator is 2, so I'll multiply above and below by the minor denominator. So that's going to give me a 2 times 7, that's a 14. X to the 1/2 plus, do the same thing here, multiply by 2. That's going to give me, what, a 14 over 3. I'm going to write it as 14 over 3 x to the 3/2 plus c. Or I could have left the x up in the numerator with the 14. Either one would be acceptable. You could write it like that, or you could have left that x up on top. So either one would have been acceptable, that or this one here. Any questions there? Here we just had variables to powers, no need for a u-substitution. So how about another one? Number 5. This is number 5 from homework 15. 5 from homework 15. What do y'all think? Do we need a u-substitution or not? Yes, if you have e to the power anything other than just a single letter, I recommend trying a u-substitution. What do you think we should try letting u equal in this case? Okay, the exponent on e is x to the ninth, so let's try letting u equal x to the ninth. Then du is what? 9x to the 8th, I agree. dx, okay. So that x to the ninth is going to be replaced with the u. We need to replace x to the 8th dx. Uh-oh, what have we got here that we don't want? The 9, so our trick is multiply by 1/9. So we have 1/9 du is equal to just x to the 8th dx. So I'll use this line here and this line here in the substitution. I've already said x to the 9th will be replaced with u. The x to the 8th dx will be replaced with the 1/9. Where does that 1/9 go? In front of the integral symbol and at du. Let's see, let me clean that up some. I have a 1/9, that's my constant factor, and I have an e, oh this works out really well, e to the u du. Any questions on the substitutions we've made so far? So now we're ready to anti-differentiate the 1/9. What do we do with the 1/9? Just bring it down. The antiderivative of e to the u is e to the u. We still have that plus c. Replace the u with x to the 9th to give me a final answer of 1/9 e to the x to the 9th plus c. Any questions? Yes.
Would the x to the 8 ever be, did you say that one time you choose the higher quantity is to the higher exponent?
I think I said choose the quantity that's raised, the one that has the quantity raised to the power. I wouldn't say it's the x to the, it's not the highest exponent that I made the decision on. If it's an e, use whatever the exponent is, if it's something other than an x. And if it's something that's not an e, let's see, something that's not an e, like let's say number 7. Okay. If it's an e to power, then I said use the exponent that's on the e. If it's a quantity raised to power, then I say use the quantity that's being raised to power. And I don't think I ever said use the one that has the biggest exponent. I think I just said the quantity raised to the power. And to illustrate what I mean by that, first of all, rewrite the square root here. This is number 7. So that's an x and a 10 minus x squared to the 1/2 dx. Well, x is to the first power. 1 is more than 1/2. So I'm not saying to use the quantity that has the biggest exponent. I'm saying try letting u equal the quantity that's being raised to the power. And the quantity that's being raised to the power here, it's just an x to the power. If you try letting u equal x, you'll accomplish nothing than just change every x to a u, which won't help you, okay? So let u equal the quantity being raised to a power. That's my suggestion. I have 2 suggestions for these things. If it's an e, let u equal the exponent. If it's a quantity raised to power, by quantity I mean anything other than just a single letter. If it's a single letter to a power, look at number 4. When it's just a letter to a power, we didn't need an exponent. I mean a u-substitution. Letter to power, no u-substitution. Here, the thing being raised to the 1/2 power is a quantity, 10 minus x squared. So I'll let u equal 10 minus x squared. And then du is what? Negative 2x dx. So the 10 minus x squared, that's going to become a u. And we need to get rid of the x dx. So we need this thing solved for x dx. What have we got that we don't want? Negative 2, so our trick is to multiply by negative 1/2. Multiply by negative 1/2. So you get a negative 1/2 du. You have a negative 1/2 du is equal to negative times negative is positive 1x dx. And so we'll use this line here and that line right there. Oh, so let's see. We said 10 minus x squared would be replaced with just the letter u. And x dx is going to be replaced with a negative 1/2. Put that negative 1/2 factor in front and a du. Oh, that's messy. Let's rewrite it. Let's clean it up some. That's the antiderivative. We have a negative 1/2 in front. What's the only thing we have here? U to the 1/2 du. Good. Any questions on those substitutions that we just made? That u equal, if you have some variable quantity raised to power, something other than just a single letter to power, try letting u equal that variable quantity. Here I had the variable quantity 10 minus x squared raised to the power, so I'll let u equal 10 minus x squared. So I'll bring down my negative 1/2. Bring down my negative 1/2 times, I have a u, new exponent, 1/2 plus 1, that's 1.5, which is 3/2, divide by 3/2, plus my constant c. This works out really nicely. Negative 1 times u is just a negative u to the 3/2. 2 times 3/2, what is that? Multiply the numerators, now multiply the denominators. What are you going to get with the 2 times 3/2? What's going to happen to the 2's? Cancel, leaving us just a 3 plus my constant c. There's only one thing left to do. What is it? Okay. So that's a negative. Replace the u with 10 minus x squared to the 3/2 all over 3 plus c. Any questions there? Okay, I think I'll take a break now.